All right, so we are doing section 4.4. We have already done a warm-up problem that is very similar to what we're doing today. We're going to be solving rational equations, okay? So we start off, the very first method that we can do on this is we can condense into a proportion, I can't talk today, and then cross multiply to solve, but we're actually not going to be using that way today. So I don't want you to worry about method one. If you wrote cross multiply in there, that's great, but we're not going to be cross multiplying today. Instead, we're going to be multiplying each side of the equation by the LCD. What is that? Least common denominator. So that's what we're doing here. Okay, so we start off. We first look, is everything fully factored? Every numerator and every denominator on this one? It sure is, okay? So now we just look at the denominators, okay? The first one that I have x minus 6. The next one I have is just x, okay? One of those is a binomial and one is a monomial. Are we all good on what a binomial and a monomial are? Is anybody a little bit confused on those two terms? No? Okay. Just in case you are, I'm going to real quick, I don't want you to write any of this down, but I just want to do a quick, brief little explanation, okay? If I gave you 5, is that a monomial or a binomial? A monomial. What about 5x? It's a monomial. What about 5x to the third, y squared, z to the third? It's still a monomial, right? Because why? No addition or subtraction sign in it. Okay, so that's still a monomial. Are we all good on that? Okay, so if I had a binomial, 5 plus x would be a binomial, right? But so would 5x to the third, y squared, z to the third, plus 10x to the fourth, y to the 14th, I'm making this up, z to the third. That's still a binomial, right? Even though it looks like it's a bunch of terms, it's really technically only 2. So are we all good on that? Okay. So I just want to make that clear. That's not an eraser. Here we go. Okay. So now we're jumping back into this problem. So I've got a monomial and a binomial. Those are not the same thing, right? No. So on my common denominator, I must keep both of them. So x times x minus 6, that is my common denominator. And I'll keep highlighting for those of you who like that. You don't have to do that, but if you do want highlighters, I've got some colored pencils and markers up here. Okay, so now all we got to do is we distribute to each fraction, okay? So going to the first fraction, just looking at those denominators. So to get from here to here, from here to here, what do I multiply by? Just x, so that's all I need to multiply that numerator by. So what's 7 times x? Just 7x. The denominators cancel, okay? Keep that equal sign. Now to get from x to x times x minus 6, what do I multiply by? X minus 6. So 4 times x minus 6 will be the right side of that equation. Okay, now, does that look like something I can solve? Yes, I would hope if you've made it to this class by now you can solve something like this. What do I do? Distribute, so 7x equals, then what? Move that 4x over because it's smaller. Divide by 3, what's the answer? Negative 8. Watch your signs. Watch your signs. Okay. How do we feel on that? Feeling okay? All right. I want you to do number 3 because it's going to work out pretty similar to that. So do number 3. You got 1 minute. Ready, set, go. So we look. What is our common denominator going to be?
Oh, you did 3? I was doing number 2.
R times R minus 1. Good. Okay, now we distribute that out to each fraction. What'd you say? R times R, which is R squared. Keep the equal sign. What's on the right side? 4 times R minus 1. Good. So now what does that equal? Okay. Do we see how our highest exponent now is a what? A 2, which means I need how many answers? Oh, 2. Remember? Do we remember when we had equations like this? R squared minus 4r plus 4 equals 0. What is that? X method. Lydia's got it going on. What goes on top? Bottom? Two things that will multiply to 4, add to negative 4. Negative 2, r minus 2 times r minus 2 is 0. Break them apart, set them both equal to 0, but they're both going to be the same answer. And what is that answer going to be? 2. Questions on that? Okay, one thing too. When you are, especially when you're taking your test and your quiz and doing your homework tonight, we do have a quiz next class, yes, and doing your homework tonight, take this answer, okay, and go plug it back into your original equation and just make sure that it works, because sometimes we're going to find out we can get an answer at the end, go plug it back in, and it's going to make our equation undefined, which means it technically would be excluded, is what we would call that, okay? I don't know if that's on your quiz next class. I can figure that out today, but we do need to make sure that we are doing that every time. So if I go plug that back in, I can use a calculator, but I just plug in 2 for r. So 2 over 1, is that equal to 2? Yeah, so this one works. So that was just my little check there. Okay, cool. Does that make sense? Are we clear on that? Okay, do number 5. All right. So we look, everything is fully factored, right? Yeah, so what do I need to do? Common denominator, what's going to be? 3 times y minus 5. Raise your hand if you agree with that. Good. Anybody get anything different? Thank you. Okay. That is correct. Now we do what? Distribute it out. Okay, so when we multiply it by the first fraction, what are we missing? Y plus 5, so I need to do y times y plus 5, right? Equals what? 3 times y plus 8. Good. Distribute, so we get now we do what? Subtract it over. So we get y squared equals 0. You did the x method, and what were your 2 factors? Y minus 4, y plus 6. And your 2 answers are going to be, yep, negative 6 and positive 4. Did both of them work?
Yes.
Yep, cool. All right, awesome. On your quiz, there's going to be one that is super duper duper similar to number 4. So that is going to be the next one that we try. Alrighty, guys. So we look, is everything fully factored?
Yeah.
Yep. What's my common denominator going to be?
3 times n.
Good. 3 times n minus 2. So what we've got here, a monomial and a binomial. Those are not the same thing. So they must be included in the common denominator. Okay. Now what? Distribute that out. So it goes to both. The first one is going to become what? M plus 3, m minus 2. Awesome. Equals what? 8 times 3, which is 24.
Oh, that's correct.
Found where you messed up?
Yeah.
So the m minus 2. To get to the common denominator, we multiply by 3, so that's what we had to do up here. Okay. You wrote it wrong? Okay. All right, now we look. What do we do here? FOIL. Good. Combine like terms, m squared minus m, sorry, plus m, yup, minus 30, because you subtract the 24 over, equals 0. Yep, I would agree.
I would also agree.
Okay, we did the x method, and what did our two factors become?
6 and negative 5.
Yeah. 6 and negative 5. You said 6 and negative 5?
Yeah.
Yeah, that's what she said.
But then whenever you solve, then when you solve, what are your two answers, Tate?
Negative 6.
Negative 6 and positive 5, good. Do both of them work? We checked? Okay.
Yeah, we did.
They do. They do, but make sure you check. All right, cool. Questions on that? All right, next page. Okay, we're gonna do number 7. So we look. We've got what as our denominators? 3n and 6, which are binomials or monomials? Monomials, one term, right? Each. So to find a common denominator, when we have monomials, we need one big term, okay? So 3 and 6 both go into 6, and I need to include the biggest variable, which is n. Okay, so you gotta include every variable that's in the denominators, but pick the one with the highest exponent. So in this case, we only had 1, and it was n to the first. Does that make sense? Okay. Now we distribute this out to everything. To get from 3 to 6n, what do I multiply by? 2n, so we do 4 times 2n, which is 8n. To get from n to 6n, what do I multiply by? 6, what is 7 times 6? Keep the subtraction sign, good. Keep the equal sign. To get from 6 to 6n, what do I multiply by? N, what is 1 times n? N. That's my new problem. Are we good on that? Anybody confused?
No.
No? You're good? Okay, now we just solve it. What do I do? Subtract the 8n over. So negative 42 equals negative 7n. Divide. What's negative 42 divided by negative 7? 6 equals n. I then go plug that in. I only have one place. So 4/3 minus 7/6, it should be 1/6. So we should be good on that. Nice. Okay. How we feeling? Good? Not too bad? Okay. Go ahead and do number 8. Give you about a minute. Okay. So we look. We've got k, 2, and k. What's that common denominator going to be?
2k.
2k. Cool. We distribute it out. Distribute it out. 1, 2, 3. First fraction becomes 6 minus equals. Solve it. Did it work? Anybody check it? No? I think it should work. It's It's not going to make any of the denominators undefined, so we're good. Okay. Number 9. How many fractions do we got here? 3. Okay, 2 is still a fraction. What's its denominator? 1. Okay, is everything fully factored? No. What can I factor? Difference of squares right here. What will that become? Okay, so I'm just going to rewrite. If you want to just scribble that one out and put it on the original, you can. So now I look at my 3 fractions. They're fully factored. I look for a common denominator, and here's what I notice. I have a p minus 2 and a p minus 2, which are the same thing. And I have a p plus 2. And I have a monomial of 1, which I'm not really worried about because anything times 1 is itself, okay? So my common denominator, I've got red and I've got blue, and I need both. So my common denominator is p minus 2 times p plus 2. Everybody cool with that? Okay. So there we go. We are going to be distributing this out to all 3, just like what we've been doing. So I first look to get from p minus 2 to p minus 2 times p plus 2. What do I multiply by? P plus 2. So I need to do p, that's my numerator right here, p times p plus 2. Keep that plus sign. To get from 1 to p minus 2, p plus 2, what do I multiply by? Both of them, right? So I've got 2 times p minus 2, p plus 2. Keep the equal sign. And now to get from p minus 2, p plus 2 to p minus 2, p plus 2, nothing or just 1. So 8 times 1 or 8. Just leave it alone. Just keep the 8. Cool. Questions on how I got that far so far? Cool. Now we've got an Algebra 1 equation that we should know how to solve. We work from left to right. Okay, we distribute. P times P. P times 2. 2P. Okay. 2 times P. 2P. 2 times negative 2. Negative 4, so I just simplified that first distribution problem, but I still have that being multiplied by P plus 2 now. Because this is one big multiplication problem. Okay, so we just multiplied the first 2 values together. Now we've got to multiply them by the second value. Does everybody see that? Okay, so now we're distributing again. 2p times p. 2p squared. 2p times 2 plus 4p. Negative 4 times p. Negative 4 times 2. And bring down this p squared plus 2p. Okay, we're almost done. Combine like terms. P squared and 2p squared. 3p squared, 2p, 4p, negative 4p, just 2p. We've got a negative 8, but I also have a positive 8 on the right that I'm going to subtract over. So negative 8 minus 8 would be negative 16 equals 0. Questions so far? Now what? X method, okay, we checked for GCF, there isn't one. We do X method. 3 times negative 16 is going to be negative what? Okay. 2 goes on the bottom. 2 things that will multiply to give me negative 48, add to give me positive 2. Negative 6, positive 8, cool. Factor by grouping. I wrote too big on this one. I'm running out of room. Huh?
We're almost running out of room.
We're all running out of room.
Yeah.
Sorry.
Yeah, we are.
I should have been a better model and wrote smaller, not left this big gap up here. Okay, we'll just zoom in. You can't do that on your paper? You can't zoom in? That sucks. We look between the first set of parentheses, what is their GCF? When we take that out, what's left? 8p and negative 16 plus 8. We have p minus 2 left. Everybody with me? So finally, my two answers are 3p plus 8 and p minus 2 is 0. Set them both equal to 0 and solve. P is going to be what? 2 and something else.
2 and 1.33.
Not a decimal. Negative 8 over 3. Yep. Cool. You're never doing that again?
No, I was talking to you.
Okay. So, here is the kicker we got. I'm going to go plug both these values back in. I'm going to start with the 2. Okay? So I got 2 over 2 minus 2. What do you notice right there? 2 over 0, which is going to be? Huh? Undefined. He's out. Are you kidding me?
So we gotta do that?
Yep. We've been doing that the whole time.
No, that's not.
And then negative 8/3, if you plug that in, that one will work. It's not going to make anything 0. Okay? So on your quiz next class, you're going to have a blank that says x equals and a blank that says x does not equal. So if you had a question like this one, you would put x equals negative 8/3 and x does not equal 2. Questions? Okay, a lot of work, but is it really that hard or is it just time consuming?
Time consuming.
Time consuming, I would agree. Okay? Awesome. Let's go ahead. Let's see what time it is. It is 11:52. I want you to do number 11. Actually, no. Hold on. Do number 12. Sorry.
I wanted to do 11.
You want to do? You can do 11 too. I want you to do number 12 though, because I don't want to run out of time, and I think this one's gonna help us better prepare for our quiz. So first thing we do, we go to this problem, and we look at each individual numerator and each individual denominator, and we see, can we simplify this? Okay, so just looking at the 3c minus 2, can I simplify that? No. Just looking at the c. Just looking at the 1. Does it have a denominator though? What is it? 1. I'm going to write that. Okay? First denominator, c squared minus 4c. What about that? Pull the c out. What's going to be left? Cool. So that's my new denominator right there. What about the other two denominators? Okay. So here's what I got. I have a c, which is a monomial. My other monomial term is 1, which I'm not too worried about because anything times 1 is itself, okay? I do have a binomial term, and I have it again right here. So my common denominator, I just need each color, right? So what is it going to be? C times c minus 4. So we take this, and we distribute. So we start off with the first fraction. To get from c times c minus 4 to c times c minus 4, what do I have to multiply by? Nothing, right? Or just 1. So I'm just going to leave that 3c minus 2 alone. Don't do anything with it. Keep the equal sign. Now, to get from c minus 4 to c times c minus 4, what do I multiply by? C. So I need to do that up top as well. What is c times c? Okay. And now to get from 1 to c times c minus 4. What do you multiply by? C times c minus 4. But it is a negative 1, right? Okay, so negative 1c times c minus 4. Cool. Now we just simplify. And I left a big gap there again, which I shouldn't have done, but it's okay. 3c minus 2 equals c squared minus c squared plus 4. Get them out of there, right, TJ? They're gone. Oh, it should be 4c, you're right. Sorry, going too fast. 3c minus 2 equals 4c. Subtract the 3c. C equals negative 2.
He did it, or are you kidding me?
He did it.
Great job.
Thanks.
Now we go up and check. Is it going to work?
Yeah.
It did? Okay, I believe you. That's my answer.
Don't believe me.
Don't believe you?
I didn't check. Pretty
You
sure.
didn't check? Did anybody check it?
No, but
Somebody go check
I know
it.
it works.
Make sure it works.
There's a lot of play.
Okay. Questions on that one? No? We feeling confident? Time is it? Okay. I do want to do this word problem. I do. I know you don't, but I do. There's going to be one similar on your test, so I would know how to do this. Okay. The one thing that I've told you about word problems, okay? They throw in a lot of extra words, right? Trying to confuse you. You are focused on the numbers and the units that you see in the word problem, okay? So we're going to read through this. A koala population in Australia has been tracked over many years, and scientists have developed the following equation, which is spelled wrong, to determine future populations of the koala. Using the function, determine the solutions to each question. Note in parentheses, it says, T represents time. That's probably important. P is population in 100s. What does that mean? Population in 100s. So like for instance, if I got my answer and I got P equals 7, would that mean that there were 7 koalas? There would be 700. What if I got P equals 700? Would that mean there's 700 koalas, or how many? 70,000, right? So I'm telling you to add how many zeros to your answer? 2. That could be important. So make sure you look at that, especially on like ACTs, EOCs, because they're going to do that to you. Okay? And they're going to have 3 answers that say A, B, C, or 4 answers, A, B, C, D. And one of them is going to say how many koalas are there, and it's going to say 70,000, and it's going to be the right one. And one's going to say 700. And you're going to get the right answer because you know how to do this, but you're going to circle this one because you didn't read the problem. And then you're going to get it wrong. So that's going to suck. So don't do that. Okay? You believe me, Tate? Okay. Whatever. You're getting nervous too?
Yeah.
Okay. So now we look. First question. What's the population when t equals 0? What do I need to do there? Set it equal to 0. Plug 0 in. 0 is t. So P of 0 is going to be 60 times 1 plus 0.5 times 0 over 2 plus 0.03 times 0. It's a dumb question. It's a real life question. What if you're going to be a zookeeper when you grow up, Tate? You're going to need to know this. Okay. We simplify this. The first option is just to type the numerator into the calculator, get the answer, type the denominator into the calculator, get your answer, and divide them. That's what I'd do regardless. Even if you do it in your head, you should check your work. Okay? But what you should get on this, these just become 0. It should just be 60 divided by 2, which is 30. But that's population. So are there 30 koalas, or are there 3,000 koalas? Thank you. 3,000 koalas. That seems like a lot. I don't know anything about them, but I don't want to be around 3,000 koalas. Okay. What will the population be after 10 years? What am I doing there? 10 years. What are they giving me? Are they giving me population or are they giving me time? Time. They're giving me t equals 10. So I need to do the exact same thing I just did, but I need to plug in 10 instead, right?
Yep.
So 60 times 1 plus 0.5 times 10 over 2 plus 0.03 times 10. Type that in. I'm not going to do it. Type in just the numerator and tell me what that is.
Oh, it's 3,060.
Three-
Numerator?
3,060?
Yeah, it would be,
I think it's 360. Okay.
yeah, not
Now type in that denominator and tell me what it is.
what?
2.3? Okay. Cool. That's right. Alright. Now what is 360 divided by 2.3? Say what? What? 156.5217. Okay. That works. So are there 156 koalas after 10 years? No. How many are there?
15,652.173.
Yep. So 15,652.17. Can you have 0.17th of a koala?
No.
Probably not. So I'm probably just going to leave it as this.
Maybe some koalas are pregnant.
Kate, you're overthinking it. Stop doing that. Okay, when will there be 7,000 koalas? So we look. Is that population or is that time? Population. Okay. So since they said 7,000 koalas, what do we have to remember about population? It is in 100s. So we need to move this decimal point back 2. So really, this is just going to be population 70 is what we need to plug in for P. Okay, so we go ahead, we plug that in. And now we solve. So we got that invisible denominator of 1. So we look for a common denominator. If one of them is 1 and the other one is something else, it's obviously going to be what that is. So 2 plus 0.03t is going to be our common denominator. We distribute that out to both. So to get from 1 to this, we multiply by 2 plus 0.03t. So 70 times 2 plus 0.03t equals, to get from this to this, we just multiply by 1, so we just leave this alone. And now we solve. So working from left to right, distribute this out. 140 plus 70 times 0.03 is just going to be 2.1t. 60 plus 60 times 1/2 is just going to be 30t. Okay, subtract 2.1t over. 30 minus 2.1 is going to be 27.9t. Subtract the 60 over. 140 minus 60 is going to be 80. Divide by 27.9. And t is going to be 80 divided by 27.9. 2.867. So we'll just call it 2.9 years. Okay? And that is going to be my answer. So let me know what questions we have, and that's it for today.